Hey guys, this is the last video in this unit. This is systems of linear inequalities. So let's jump right in and review how we graph systems of inequalities. So this is a basic two-step process. It works just like graphing systems of equations and regular linear inequalities. We're just putting those two things together. So the first step is to graph and shade each linear inequality by itself, and then second step is to figure out where the shading overlaps. That is our solution region. Okay, so let's jump into number one and just review how this works. So we have y is less than or equal to negative 2/3 x minus 1. So this first line, I'll go ahead and do this one in blue. We'll start at a y-intercept of negative 1. The slope is negative 2/3. So it's going to look like this. It's a solid line because it has the equal to bar, so we'll connect the dots here. And then our shading for the line, and I would do this very light if you're doing it with pencil. Hopefully you are. Our shading for the line is going to be down here. Okay, but do it very lightly when you shade there. Okay, our second line, y is greater than or equal to 1/2 x minus 8. Y-intercept at negative 8, and it's got a positive slope, 1/2. So it's going to look like this. We'll also connect it with a solid line. The shading for this line is going to be above, and again shade very lightly. When you graph your two separate lines, sometimes it helps students to use two different colors, so you could do one in pencil and one in colored pencil. If you're going to use something that won't erase like pen or highlighter, just be sure you're being really careful with your lines, because obviously if you make a mistake it's tough to erase those. Okay, so these are the two different shading regions, the blue and the red. The solution region is where the blue and the red, in my case, overlap, and so that would be this region here on the left. So I'm going to color this in a third color. I'll just choose purple because, you know, red and blue make purple. And so this region right here is what you need to indicate is your final solution region. You can do that by making it a lot darker than the others, or you can make it a third color. You could also, if you wanted to, just make a, maybe with a black marker or something, or black pen, a dark S, just so I can see that this is the solution region right here. So what this region means is any point inside this region will be a solution of the system, meaning it works in both inequalities. Okay, if you pick a point that's just inside the blue part but not the red part, that point would work in the first inequality, not the second. Points that are in the red part but not the blue part work in the second inequality, not the first. And then, so you have to have points in the purple part to work in both inequalities. So that's what that represents. Okay, we'll try this a few more times. Number 2. First inequality, y is less than or equal to 3/4 x minus 4. So y-intercept at negative 4, and then a positive slope of 3/4. And we'll connect this with a solid line. And it's less than or equal to, so we're shading below that line. Okay, second inequality, y is greater than negative 7. So there's my y-intercept of negative 7. This is a horizontal line, and it's going to be dashed since there's no equal to bar, so we're going to just connect a dashed line through that y-intercept. And our shading there is going to be above the line. And so our crossover region is going to be here on the right. Everything in this sort of right triangle-ish region will be our possible solutions. Okay, going down to number 3, 7x plus 3y less than or equal to 18. So I need to put that equation in slope-intercept form first. So that means I'm going to subtract 7x from both sides to get negative 7x plus 18, and then divide everything by 3 to get y is less than or equal to negative 7/3 x plus 6. So a y-intercept at positive 6, and then I'm going to go down 7 and right 3. This is a negative slope, so the line should be decreasing. And we'll connect those dots with a solid line. Second inequality, I need to subtract 2x from both sides, so I get negative 3y is less than or equal to negative 2x plus 9. Divide everything by negative 3, so I get y is greater than or equal to 2/3 x minus 3. And I'll also connect these with a solid line. Okay, let's do the shading since I forgot to do that for the blue line. So this shading for the blue line is below the line, so that's going to be this direction here. And the shading for my red is going to be above the line, so that's going to be this region here. So my crossover region, the one I'll do in purple, is this region here on the left. So it's going to be everything in this region. Okay, finally number 4, 4x minus 5y is greater than negative 5, so I need to put that in slope-intercept form. Negative 5y is greater than negative 4x minus 5, and then divide everything by negative 5, so we have a flip of our inequality sign. We get y is less than positive 4/5 x plus 1. So this is what that first line is going to look like. And we're going to connect those with a dashed line. And our shading is below the line. Okay, number 2, x is less than negative 1. That is a vertical line through an x-intercept of negative 1. It's going to be another dashed line. And less thans for verticals, we shade to the left. So our shading will be going this way. And so my red and my blue are crossing over in this region on the bottom left. That is my solution set for this system of inequalities. Okay, moving on to the back, we have a couple more questions. Number 5 is asking us which points out of the 6 I've given you are solutions to the system of inequalities below, and we're going to check all that apply. So remember, for a point to be a solution to a system, it has to work in both inequalities. So if I start with the point 1, 1, to figure out whether this is a solution or not of the system, I'm going to plug a 1 in for x and a 1 in for y into both of my inequalities. So in my first inequality, that's going to be a 1, and then 6 times 1 is 6, so this will be 1 minus 6. And you're asking yourself, is that greater than negative 48? Well, 1 minus 6 is greater than 48. Okay, so I would say yes, that works. And then if I plug in a 1 for x and a 1 for y into my second inequality, I get 2 times 1 is 2. 3 times 1 is 3, so 2 plus 3, is that less than 9? Yes, 2 plus 3 is 5, that's less than 9. So this works in both inequalities, and so that means that 1, 1 is a solution for this system. If I try 9, negative 2 next, We plug a 9 in for x and a negative 2 in for y. Well, we're going to have 9, and then negative 6 times negative 2 is plus 12. So 9 plus 12, is that greater than negative 48? Well, yes, that is. Now let's try it in the second inequality. 2 times 9 is 18. 3 times negative 2 is a minus 6, so we get 18 minus 6, and is that less than 9? Well, 18 minus 6 is 12. 12 is not less than 9, so that would be a no. So that means 9, negative 2 is not a solution to this system. Okay, what I want you to do now is pause this video, and I want you to try the other 4 points, 3, 4, negative 2, 6, negative 8, negative 3, and 4, negative 7. Determine whether they're solutions or not, and then once you've done all that, click play to check your answers, please. Okay, if you did this correctly, you should have found that 2 more points work. Negative 8, negative 3 works for this system, as does 4, negative 7. 3, 4, and negative 2, 6 did not work because of the second inequality there. Okay, so that's one way to test whether or not different points are solutions of a system. Another way you could have done this is you could have just graphed this system on graph paper, had you had it, and then found the shaded region, and then any of these points that did not lie in the crossover region, okay, like the regions in purple that we did in examples 1 through 4, would not be solutions. So if you had done that correctly, the only points from this list that would have been in that region would have been 1, 1, negative 8, negative 3, and 4, negative 7. Okay, so that's another way you can determine what points are solutions of a system. All right, the last problem we have here is a word problem. To raise money to attend Boy Scout camp, Alec is selling popcorn. Small bags sell for $4 each, and large bags sell for $6 each. He needs to earn at least $300 to attend camp. He will also earn a badge if he sells at least 60 bags total of any combination. So we're going to write a system of inequalities to represent this situation. So for this, our unknowns would be the number, or the number of bags he's selling. 2 different types of bags. We have small bags, so that we could let x be the number of small bags. And we have large bags, so we could let y be the number of large bags. And so for this problem, Alec's concerned about number 1, getting to camp. To get to camp, he has to sell at least $300 worth of bags, and he'll make that money by selling small bags, which are $4 a piece. So he's going to make 4 times x for the number of small bags. And then large bags, $6 a piece plus 6y, and that total amount needs to be greater than or equal to 300. Okay, the second thing he wants to do once he attends camp is earn a badge. And so he earns a badge by selling at least 60 bags. It doesn't matter the dollar amount, just 60 bags of any combination. So x plus y is going to be the total number of bags. That needs to be greater than or equal to 60. Okay, so we're going to graph the system now, putting these in slope-intercept form. So 4x plus 6y is greater than or equal to 300. That's going to be 6y is greater than or equal to negative 4x plus 300. And dividing everything by 6, we get y is greater than or equal to negative 2/3 x plus 50. And the second inequality, we just have to subtract x from both sides, and we get y is greater than or equal to negative x plus 60. What I'm going to do now is pause the video, and I want you to graph this system on this coordinate plane here. Again, we're only using quadrant 1 since we're only concerned with positive values of x and y. Once you have this system graphed and the solution region shaded, press play and check your answers, please. Okay, so if you check your graph, it should look something like this here. Your shaded region is going to be above both of the lines, so it's going to be this region here in purple. Part B of this problem asks us to use our graph to give 2 possible combinations of bags of popcorn that Alex can sell to attend camp and earn his badge. So again, this shaded region represents the number of bags he could sell to both attend camp and earn the badge. So we just need to pick any 2 points from this shaded region, and again, your answers might vary from mine. One point I see that lies within this shaded region is the point 1060. So that would be this point right here. So that means that he could sell 10 small and 60 large bags. Another point I see in the shaded region is this point here. This is 50-40. And so this means that Alec could sell 50 small and 40 large bags. Okay, any questions you had over this video, feel free to write those down and ask those the next time you're in class. Until then, folks, have a nice day. You're all wonderful people. Take care.